Hi guys. Today we're going to talk about quadratic transformations. So we're going to be transforming parabolas in these graphs. And so we have 6 problems to do today. Every problem gives us a little bit of something. It either gives us a graph or it gives us an equation or a description of the transformations that are happening. And then we have to fill in the rest of the information. I know that this is a little bit different from what we had been doing because we had been talking about standard form of parabolas and the directrix and the focus and the focal chord and things like that. Today we are kind of shifting. It's funny, we're talking about transformations and we're shifting focus back to kind of vertex form. And so if you remember, transformations can be modeled by kind of vertex form. And in the past, we've talked about transformations of like absolute value functions. And so I'm just going to show you my notes key from the absolute value transformation notes. And so it kind of looks like what you have on your notes right now, except for it's got absolute value instead of this stuff being squared. And so it tells you all of the things that each of the variables do, or, numbers in those certain locations, all the things that they do. And so what I want to do right now is just kind of review you on that before we begin really getting into writing those quadratic transformations. So we're going to look at vertex form. And the first thing that you might notice about vertex form is that it's got the vertex in it. And so H and K make the vertex. Well, the H value is the X value of the vertex. So it tells you, instead of plotting the vertex at 0, 0 like the parent function, it tells you whether you should move the vertex to the left or to the right. And so this H value is a shift left or right. That's what that H value tells you. And remember, everything in parentheses is a lie, because we have this minus right here. So if you have x plus 3, well, that means you're shifting 3 to the left. If you have x minus 7, well, that means you're shifting 7 to the right. So keep in mind that everything in parentheses is a lie. Now the k value, we've since learned, is the y value of the vertex. So whenever you plot the x value of the vertex, you start at the origin, maybe your x value of the vertex is 2. Then your k value of the vertex is how much you go up or down to plot your new vertex. So maybe your vertex is at 2, 6. Well, that means that you go to the right 2 and you shift up 6. Maybe your vertex is at 2, negative 5. So you go over 2 and then you shift down 5. And so this k value is what shifts you up or down. And then the final thing we want to talk about here is the A value. The A value can do a couple things. If you have a negative, then you reflect across the x-axis. So if you have a negative A value, that tells you the parabola opens down and you need to reflect it across the x-axis. So you need to make it open down. But A could also stand for a vertical stretch or compression. So it's kind of like your scale factor for your parabola. So a vertical stretch or compression. And before we do anything else, Before we do anything else, I want to make sure that you understand the parent function. Remember that the parent function is f of x equals x squared. We don't have an h value, it's 0, and we don't have a plus k visible because it's 0, so the vertex is at 0, 0. And then we don't have an a value visible because a is just 1. I'm not stretching or compressing or flipping, like reflecting or anything like that. And so when I graph my parabola for my parent function, every time I move to the right 1, I'm going to move up an odd number. So I'm going to move to the right 1 and up 1. And then from there, I'm going to move to the right 1 and up 1, 2, 3. And then to the right 1 and up 1, 2, 3, 4, 5. Same thing on the other side, and this is called the quadratic pattern. So we go up 1, we go up 3, we go up 5, and we would keep going up by odd numbers. And so that makes that quadratic function, that parent function. So over 1 up 1, from there over 1 up 1, 2, 3, from there over 1 up 1, 2, 3, 4, 5. So that's that parent function. And the quadratic pattern is 1, 3, 5, 7, 9, and so on. So that's the parent function. And I just want to make sure that you are aware of what the parent function is. And that's why I did it in kind of a lighter color, because I don't want it to clash with the red of my work. So let's look at part A. In fact, you'll notice this big box and then this f of x equals, that all goes together, and this goes for graph A. So all of this is one problem, belongs to one problem. Okay? Now they didn't give us any description or an equation, but they did give us a graph. So from this parent function, we need to figure out how this was transformed. So it might be a good idea to write a description first and then try and come up with the equation. So here's my new vertex. From the parent function to this function, function A, how did it get shifted? It got shifted to the left. How many units did it get shifted to the left? 8 units to the left. So shift left 8 units. So if you shift left 8, you land here. And then you have to shift up, right? How many units do you shift up? 1, 2, 3, 4. So shift up 4 units. My vertex here is -8, 4, so that might be helpful to know. I notice that my A value, the thing that shows me if I reflect or vertically stretch or compress, it shouldn't be negative because my parabola is opening up. But instead of going to the right one and up 1, how many do you have to go up when you go to the right one? You have to go up 1, 2, 3. So that means that my A value is 3. Because instead of going to the right one and up 1, I have to go to the right one and up 3. That 3 is my A value. So I vertically stretch by a factor of 3. So let's figure out what my equation would look like. I'd start out with f of x equals, which we have that here. We had a vertical stretch by 3, so that means A is 3. I'm going to open my parentheses and put an x. I have to figure out what my shifting horizontally was. Well, I shifted to the left 8, so instead of putting -8, I'm going to put +8 squared, because everything in parentheses is a lie. And then how much did I shift up or down? I shifted up 4, so I should add 4. And that creates my quadratic transformation equation. Not too bad, right? So let's look at B. No description, no equation, but we have a graph. So from my parent function, the green one, to my new function, here's the vertex, how do you shift? You move to the right 6, you shift how? You shift down 1, and then do we have any reflection happening? We do, because the graph is opened down. So we reflect over the x-axis, And then let's check my a value. So whenever you go to the right one, if the parabola is opening down, you should be able to go down one, and that doesn't happen. In fact, we don't have a nice pretty point until right here. And I notice that the graph goes to the right 1, 2, 3, and down 1, 2, 3. 3 and 3. So what that means is this graph has a vertical compression by a factor of, and because we're compressing, that means that we have a smaller number. So whatever this distance here is, 1, 2, 3, and 1, 2, 3, that becomes your denominator of a fraction. So by a factor of 1/3. That's what that looks like when you have a quadratic transformation that's a vertical compression. So if we go to the right 3 and down 3, well then that means a is 1/3. I guess we should say negative since it is reflecting over the x-axis. So let's try to create that equation. We have f of x equals. Did it reflect? Yes, so a should be negative. Did it stretch or compress? Yes, by a factor of 1/3. Parentheses x. Did it shift left or right? Yes, it shifted right 6. So we don't want to put plus 6, we want to put the opposite, minus 6 squared. And then did it shift up or down? Yes, it shifted down 1, so minus 1. Okay. So now let's look at C. C doesn't give us a graph, C gives us an equation. Let's try and pick out the things that are happening in the equation. So in the equation, we have this minus 1, so where are we shifting? That's in the place of h, so we're either shifting left or right. If you have minus 1, are you shifting left or right? You're shifting right. Whatever is in parentheses is a lie. What about here? What does that mean? That means we reflect over the x-axis. And then what does this mean? That looks like it goes right here, so it's a shift up or down. If we have plus 3, then we shift 3 up. All right, so let's do those transformations. And again, we talked about this when we talked about absolute value transformations, but there's an order that you do your transformations. And it's always BHAK. The B value is usually here, but we don't have that. So we should be transforming this in the order of HAK. So shift left or right, vertical stretch, compression, or reflection, and then shift up or down. So that's why we did these in this order. So I'm going to shift from 0, 0. I'm going to shift to the right 1. I'm going to, instead of open up, I'm going to know that I'm opening down. That's my reflection over the x-axis. And then I'm going to shift up 1, 2, 3. I don't have any kind of vertical stretch or compression, so I'm just using my quadratic pattern, 1, 3, 5, 7. So I go over 1 and down 1, over 1, down 1, 2, 3, over 1, down 1, 2, 3, 4, 5. Same thing on the other side. Over 1, down 1, over 1, down 1, 2, 3, over 1, down 1, 2, 3, 4, 5. So this parabola is the parabola for the equation C. Okay, so I want you to take a moment, try and think about that, and move on to part D. Part D is similar. It gives you an equation. You have to fill in what is happening, what transformations are happening, and then you have to graph. So keep in mind that you should be comparing your equation to this form and see what the description of the transformations are. So pause your video and try to do this problem. So your +4 here means you shift to the left 4. Your 2 here means a vertical stretch by a factor of 2. So when you graph, you start at the origin, you shift to the left 4, parabola opens up because there's no negative a value. And then in order to perform a vertical stretch by a factor of 2, you just multiply your quadratic pattern by 2. So instead of going to the right 1 and up 1, you go to the right and up 2. Instead of going to the right 1 and up 3, you go to the right 1 and up 6, because 3 times 2 is 6. So 1 and 3 and 5 and 7 are being multiplied by that scale factor of 2. So you're really going up 2 and 6 and 10 and 14, because you're doubling that 1, 3, 5, and 7. So your graph should look like this. Ignore these 2 points because those were mistakes. And now let's look at E and F. So here we're given information about the transformations. We have to write the equation, and then we have to graph up on the top. So here we need to reflect f of x equals x squared, the parent function, across the x-axis. So that means a is negative. We need to translate left 6 and down 2 units. So left 6 means 6 to the left, so instead of -6, you have +6. And down 2 means -2. And we need to apply a vertical scale change, a stretch, by a factor of 2. So that means that not only is a negative, but it's -2. So when I go do that transformation, I'm going to start at the origin. My h change is shifting left 6. I need to reflect across the x-axis, so I'm going to open down. And I also am going to be stretching by 2, so instead of my quadratic pattern being 1, 3, 5, 7, I'll double them. So 2, 6, 10, 14. And I also need to go down 2 units to find my new vertex. So let's do that stretch. Instead of over 1 down 1, it's over 1 down 2. Instead of over 1 down 3, it's over 1 down 6. 1, 2, 3, 4, 5, 6, and I don't have any more space. So let's do it on the other side. Over 1 down 2, over 1 down 6. And this is the graph for problem E. Now I want you to do something similar, and I want you to look at problem F, read the transformations that are happening, write the equation, and try to graph that parabola. So pause your video and try F. So if you translate right 5 units, that's -5 in parentheses. Up 4 units is +4 at the end. A vertical scale change or a compression by 1/2, so 1/2 is your a value. When you graph, your new vertex will be shifted to the right 5 and up 4. So from the origin, right 5, up 4. And then if your compression is by a scale factor of 1/2, 1 over 2, that means that instead of going over 1 up 1, you need to go over the denominator and up the denominator. So over 2 up 2, over 2 up 2.